Hey everyone, out on a walk today, and today going to be talking about a really interesting pattern that I've been using in Next.js for live data updates in applications. So when we're building apps, often we want a few things. First thing we might want is a really nice initial rendered experience. So the user goes to a particular page, and then when they see that page, they initially see, all the data is just there straight away, right? That's kind of the most ideal. They don't need to see any spinners or wait for anything. It's just all there. Okay, well, if the server's doing all of the data fetching, then we'll just refresh the data as the user moves around in the application, which is fine, except it's not great for experiences where there are multiple users engaging with the same data and you want that data to be live updated. So there's a few things you might do to solve that problem. One solution is that you may introduce some sort of WebSocket connection to a server that when the data changes, you are pushed and notified about those changes and you can make them locally. The challenge with that approach, though, is that you often end up with two different data paths. You end up with one data path, which was for your initial render. So, all right, I'm getting all the things I need for this page, render it out. And then you have to have sort of a different mechanism on the client for when you're getting these notifications to handle those changes coming in. And so what you can end up having is sort of two almost different ways of doing the data, and you kind of also then are teaching your server how to get data, and then you're teaching your client how to get data as well, because if it needs to either be directly from the WebSocket or maybe it has to do a fetch itself. And so you kind of got these two paths. So there are a few solutions to this problem. A really simple one is you just say, okay, the server's not going to worry about data anymore. It's just going to render the shell, and then the client's going to be the one that handles all of the data fetching, updates. And so that way it can all be in one place. I think that's a fine solution, except it's kind of suboptimal from a user's perspective because they don't get that really high polish initial view. And it also means sort of inherently that your client's going to be heavier because it has to now have all the code to handle getting new data and listening for changes and sort of handling all of that. So there is a pattern that I've seen as well, which is a way around that a little bit, which is you effectively just create an endpoint, which is the data for any given page. And then on just like a poll, you just basically get the new data and, patch your local with it. Now that sounds kind of gnarly, and it is. You still have the two data paths. Your client still needs to be aware of this. It needs to be taught like where to get this data, how to query it, how to patch the local. So, but it means at least with that approach, you are consolidating how you retrieve data into potentially a single place. So you can have your server-side render, call this, this function to get the data for the page, as well as, the client directly can call that. So that is nice, and you do get that consolidation, but it's not ideal because, again, you're still teaching the client how to do things. And it's also not super responsive. Like doing a poll is a whole kind of world of kind of complexities as well. A challenge with polling is that you can end up doing a lot of redundant stuff. Like if nothing has changed, you're still polling at some frequency saying, give me the latest data. And so you can invent mechanisms to sort of create flags or computed flags to represent whether data has changed. And sometimes those flags are not necessarily reflective of reality. I won't go into that heaps here, but it's sort of, I mean, it's an okay-ish solution, but not ideal. So with all that sort of context in mind, I've been using this really interesting pattern in a Next.js application that uses Supabase. So Supabase gives you real-time subscriptions to tables in your database. It spins up its own little WebSocket server. And so you can connect to that and it will tell you when changes happen. So that's really cool, except you're still back in that problem where, okay, if I'm going to use the server and I want to get that really nice initial load experience, I'm using that Supabase calls on the server. And then, well, what do you do from the client? Like, okay, the client's pushing you updates. What do you do with that? Do you patch your local? I basically have these two data paths again. So Supabase has a few offerings. One of them is a server package, which allows you to correctly handle the session and do the querying for the data on the server. Great. And they also have a client that you can use in people's browsers. The trouble is that client is really big. I'm talking like 50 kilobytes minified. It might even be gzipped as well. Like, it's a really heavy library. And for the app I'm building, I just really don't want to add that weight to the page. So what I did find is that they've got a sub package called at Supabase /realtime. And that is specifically just the logic for handling the WebSocket connection. And I got AI to help me, but I basically just ended up cutting out all of that other part that I didn't need authentication. I didn't need to be able to query. I didn't need to do anything else with Supabase on the client. All I want was just to be notified about changes to particular tables. And there was a little bit of extra stuff I had to do to use that package directly, but for the whole, it brought 50 kilobytes down to about 20 kilobytes. So much more reasonable chunk. And so I'm using that little real-time library as a signal that something has changed. And so I actually lazy load it. I don't have to block the initial page render for it. I can defer its loading and then it can connect and be notified about when changes happen. Okay, so now I get notified about when a change has happened, but what then, right? Because even though that a change has happened, like you then need to figure out what do you do? Do you patch your local data? What do you do? And I didn't want to have multiple data paths in my app. And so what I stumbled into, and this might be, commonly known, but Next.js has these really interesting APIs. The first one being router.refresh, which you might think, oh, what does that do? That just refreshes the page. No, what it actually does is it recomputes the React server components that were used on the page on the server, and then will give the new data back into your application. So the flow is the Supabase client says something changed. You call a router.refresh. It does all the back-end queries again that were needed for the page, and it comes back to the page. And then it just comes into your app as props in the same way the stuff originally came into your app as props, or the data that is, and then you're sort of just good to go. And that's a really interesting pattern. So firstly, you can also wrap that in a transition. So you can sort of do this data update, a React transition. So you can do this sort of prop change update as low priority update with React, so it can kind of get thrown away, or it won't block other work happening with React on the page. And so you use Supabase to get the signal that something changed, but then the source of truth, the thing that's actually doing all the querying, can all remain on the back end. Now, there is a little bit of complexity there. So the trouble is you might be doing a lot of redundant work, right? You query the back end, again, you get all the data for the page. Like maybe you actually needed to change one field in one place, but you've effectively re-queried the whole page. So that's something I'm keeping my eye on. At the moment, it's not a big issue for what I'm building. It's not the queries I've kind of optimized, and there's not a lot of data even in the worst cases. So it feels like a nice trade-off there for that simplicity of mental model that something changed, call the server, get it. So it sort of goes back to that model of, polling, but it's a little bit more optimized in that you actually know when you should poll, and you don't sort of call the server if you don't need to, if nothing's changed. They also have another API, which I think is called revalidate route. I can't remember. I'm not in front of my computer right now. But it's the same idea as router refresh, except you can just do it for particular segments of your route. So depending on how you've structured your layouts, it means you can be a little bit more nuanced about which areas of your page are actually sort of having their React server components re-executed. Instead of just everything on the page, it could just be, say, a section of the page, which does help with that potential overworking of the server. You can put the revalidate path in React Server Actions themselves. So if you're wiring up a React Server Action with a form and it's got the is pending flag, like you can actually then have that is pending flag will be true until the server has finished recomputing all the React Server components needed for that route segment. So you can still have nice loading experiences. You can show spinners while it's computing certain parts, or it just gives you a lot of flexibility. And this model I'm finding really interesting because it means that I can keep my client light. I can put all the data fetching, munging logic on the server, and the client effectively becomes quite naive. It doesn't really have to know. All it needs to sometimes do is say, like, reach out to Next and say, hey, I need to get the latest data. And Next then takes over, recomputes the React server components needed, and gives it back to the client. And I'm using WebSockets as effectively just a signal that something has changed and that loop needs to be rerun. And if you combine that whole story with just very basic, local, optimistic updates, you can have a very rich, quick, snappy feeling application that's also real time while keeping the client very, very light. The main drawback with this approach is that you may end up doing more work in terms of data fetching on the server than you needed to. Let's say you just used WebSockets and all the data that was needed for changes was communicated over the wire. Conceptually, you could patch those changes locally, and then you don't need to call the server again, right? So you minimize the amount of work you need to do on the server. And you do introduce a little bit of latency as well, because you have the WebSocket telling you a change happened, and then you call the server to say, give me the change, right? So you've got that extra hop, which, if you're doing a very, it has to, where an application where those updates have to be lightning fast, potentially just using the WebSocket directly is the right move. But if you're happy to wait a little bit more, enough time for another round trip, this model becomes really interesting. This model where I'm using the WebSocket just as a signal that something has changed, and then letting the server kind of own all the data fetching and passing, it feels really clean. It kind of feels like React in a way. You've got the server as the owner of the state, and it just sort of gets notified by the WebSocket that something's changed, and I can just kind of keep this loop going. In general, I'm trying to keep my clients as light as possible and trying to do as much work on the server as I can. With the aim, the big aim here is to create an amazing user experience, something that feels snappy, feels fast. And in my adventures so far, the more things you can get the server to do, and the lighter you can make your clients, the better experience those clients will have within reason. So yeah, this is just a really interesting pattern. I don't know if it's going to scale out or how many users it's going to scale out to. It may completely fall over, but so far it's been a very interesting and successful and enjoyable pattern to work with. Anyway, I hope you found that interesting, and I'll catch you later. All right, bye.